Hey guys, so we made it through the first unit in Edmentum for geometry, which was circles, and that was what we had left off with before we got this unexpectedly long break, and so that's why I started with that, because hopefully you remembered some of that. Our next unit is probability, and with probability there's a lot of weird looking formulas and things like that, so I thought it might be better just to try to talk you through the tutorial, because in my experience, they can be a little frustrating to go through. So right now, I am on the first probability tutorial, which is sample space. Okay, and I'll just click through till I get to the important stuff here. We're going to describe events as subsets of a sample space. This first part is just kind of coming up with a little scenario about, hey, you're going to try to raise money by doing a casino night. I'm not going to worry too much about that. We're not going to watch that video. But we're going to talk about probability and odds, which is why they use the casino example, because they need that a lot there. Anyway, so to talk about, the first thing we talk about is something called fair odds, and if you click on this, it'll tell you what it is. Usually when we talk about odds, we're talking about odds against. So if a horse has odds 50 to 1, and then another horse has odds of 10 to 1, the 50 to 1 is more of a long shot. That basically means the horse would lose 50 times for every one time that it wins. So the closer those two numbers are, the closer to fair odds they are. So like 1 to 1 would be fair odds. Every casino is going to have a house edge, because if the house doesn't win, the house doesn't make money. So they always kind of keep that. So that's kind of what all of this here is explaining. Here is an article that you can choose to read if you want to, but like I said, I'm going to kind of walk you through this because math is it's hard to read. Like, it's even hard for me, and I know what they're talking about. So let's move on. So we have this activity. I'm going to walk you through it. In this one activity, the first thing they want us to do is, we have this game called Odds Out, and the player will roll 2 6-sided dice. Now, the player gets the points if the product of the two numbers is odd, so success depends on the chances of getting an odd one. So we want to find the number of outcomes in the sample space. Okay, now the sample space is this N of S, and it looks really weird, but all that means is like how many possible outcomes are there. Okay, and if you are rolling 2 dice, we're going to kind of go back and forth here. If you are rolling 2 dice, well, first of all, if you're just rolling 1 dice, you have the possibility to get a 1, a 2, a 3, a 4, a 5, or a 6, right? So if you're only rolling 1 die, you'd have 6 possible outcomes. However, if you're rolling 2, you could get a 1 on the first one, but then from there you could get a 1, 2, I'm going to run out of space, 4, 5, 6. So you have 6 options after you roll a 1 first. And you're going to have those same 6 options when you roll a 2. And those same 6 options when you roll a 3. So basically what that means for the first roll, sorry, this is a little messy, I'm writing on my touchscreen computer, there are 6 outcomes that could happen. For the second roll, there are also 6 outcomes. So to get the total number of outcomes or sample space, you're going to take 6 times 6, which means there are 36 possible outcomes. Okay? So if I come back over here, the number of outcomes are 36. And I don't know if you get to figure this out, but on the lesson activities, you can hit submit, and then it'll show you what a sample answer is. And we got it right, 36, yay. Okay. On this next one, list and count all of the outcomes for event E, in which the product of 2 odd numbers is rolled. So I'm going to kind of write these as a set of ordered pairs. Now, the product means I'm going to multiply them. So if I get a 1 on the first roll and a 1 on the second roll, 1 times 1 is 1, that's odd. If I get a 1 on the first roll and a 2 on the second roll, now those multiply to 2, so that is not odd. But if I got a 3, that would be odd. And then if I got a 1 on the first roll and then a 5 on the second roll, 1 times 5 would be odd. So those 3 are possibilities. However, there's more possibilities, because I could get like a 3 and a 1. I could get 3 and 3. I could get 3 and 5. I could get 5 and 1. Well, that's not 5. 5 and 1, 5 and 3, and 5 and 5. Right, so basically, if I want two numbers to multiply to an odd number, both numbers have to be odd. So these are all of the possibilities of ways that I could roll 2 dice and get an odd number. And if you count them up, that is 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities. Okay, so 9 possible ways to roll 2 die, and have them multiply to an odd. Okay, and you can look and see, yay, we got it right. Okay, good. On this next one, find the probability of getting an odd number. And when we talk about probability, what it is, let me add another slide here. The probability of an event is going to be the number of ways it happens over the total number of ways. Okay, so that's how we find the probability of an event, and that's what that notation means. I know it looks weird. So here, if I want to know the probability of getting an odd, what I would do is I'd first of all take the total number of ways we can get an odd, which we said was 9, and then you divide that by the total number of outcomes, which was 36. Okay, so 9 over 36. We always want to try to reduce that as much as we can. So 9 divided by 36. You can use your handy dandy calculator and make it a math fact. You get 1/4. Okay, so there's a 1/4 probability that you're going to roll an odd number, which could be also 0.25. Okay, so again, to figure out the probability of an event, it's going to be the number of ways it could happen over the total number of ways. On this fourth question, it says what happens when the player performs this trial 2 times. So we can look at this. There's a simulation. And so you can pick how many dice you want to roll, how many die you want to roll. I want to roll 2, and it'll simulate it. And so here I have a 4 and a 6. Those multiply to not an even number, or not an odd number, I'm sorry, those multiply to an even. So we could say, okay, we tried it once, but we did not get an odd. So we can roll again, and I have 4 and 2 also not odd. We roll it again. Those also 4 and 6 not odd. We roll it again. 6 times 4 not odd. 5 times 5, 25. Okay, cool. So out of those 5 rolls that I got, only one of them was odd. So if I'm going to come over here and try to figure out this F equals NE over N, F means that is what we call like the observed probability or your actual results. N sub E is the number of times the event occurred, so the number of times we got an odd, and N is the total number. So here I would place like, okay, we got that odd number once, and then F would be 1 divided by 5, which you can use your handy dandy calculator, and get 0.2. Okay, and then you can run this however many times you want, keeping track of whether you get an even or an odd. That's even, even. Okay, hey, there's another odd. Okay, and so you could kind of fill this in. But if you look here at the sample of kind of what you're getting, you can see all those numbers, while they're not exactly the same, they can be pretty close. And that's what number 5 is saying. What is the relationship between F? Remember, F is the actual results. And P of E is what we call the expected or predicted probability. And we have predicted that you would have a 1 in 4 0.25 chance of rolling an odd. And if you look here, all of those numbers are pretty close to 0.25. Okay, they're not going to be exact, but they're going to be pretty close. And if you look, the more times we rolled it, the closer it gets. So the relationship here is that the more and more times you roll it, you're going to get closer and closer to that predicted or expected probability, which is what this is saying. Self-evaluation, I think we all did a great job, so I'm going to move on from there. Okay, and so let's just talk a little bit more about sample spaces. Every experiment has a different number of sample spaces. So we talked about the dice. if you're rolling 2 die, then there was 36 possibilities of what could happen. However, if I have like a spinner here, there's 3 colors here. So it's pretty easy to figure out. If you spin it once, you have 3 possible outcomes. You could get red, blue, or yellow. However, let's say you spin it twice. Okay, and that's what this diagram down here is saying. If you spin red on the first time, then the second time you could get red, blue, or yellow. So you could have red, 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 blue, red, yellow. If you spin it blue first, you could have red, blue, or yellow. So you could have blue, red, blue, 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 yellow. And so if you count here, there's actually 9 outcomes if you spin it twice. So the sample size on that would be 9. Another one is, this is a lot of words. I know if I let you guys just go off and do this on your own, you just wouldn't read this. Okay, but the first one is saying, what's the possibility of guessing a 3-digit passcode? So let's come back to a Smart Notebook. It's not as easy as on the Smartboard. Okay, so the first one, we have a 3-digit code. So basically, when you have a 3-digit code, there's 3 numbers you have to guess. And if we just say any 3-digit code, then in this first spot, there are actually 10 possibilities. And you may be saying, well, numbers only go up to 9. But if you count 0, so you could have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you're counting on your finger, you'll see that there are 10 possibilities there. Okay? And then in the second one, there's also 10 possibilities. And in the third spot, there's also 10 possibilities. And just like with the dice, we're going to multiply those together. So if you have a 3-digit passcode, there are actually 1,000 different 3-digit passcodes possible. And so the probability of guessing it, of you getting that one code right, would be 1 over 1,000. Okay? Now this next thing, it says, what if no digit in that passcode could be repeated? Well, it's going to change things a little bit. Okay? If no digit can be repeated, that's going to change these, that's going to change this, and we'll get rid of that. Okay? So if no digit can be repeated, you still have 10 choices for that first one. So now for that second one, you only have 9. And then for that third one, you only have 8. Okay, so you're going to do 10 times 9 times 8, which actually then only gives you 720 possibilities. So when it comes to your chances of guessing that, you actually have a little bit of a better chance if you can't repeat anything, because you have 1 over 720 possibilities. 1 is the number of correct codes, 720 is the total possibility. And that's what they're saying here. Okay? So let's answer this question. If the spinner is divided into 2 sections spun 5 times, how many possible outcomes are there? 2 sections spun 5 times. You have 2 options on the first one, 2 on the second, 2 on the third, 2 on the fourth, 2 on the fifth. Okay? So you have those are your possibilities. You multiply them together. That's going to give you 32 options. And then, yeah, we got it right. Okay, good. All right. So let me just see how I'm doing on time here. I guess we'll do one more section here and then I'll start a new video. So then more probability theory. Here, this formula right here, it looks really crazy. It does, but what that is saying, if I break that down, the probability P of E equals N of E over, go back. No, sorry. So much easier on a smartboard at school. Okay, so let's break down what all this is. Okay, this right here is the expected or predicted probability. And that's what we get, when we said, like, if you were to spin a spinner, you have a 1 in 3 chance of getting a certain color. N of E is the number of ways a specific event can occur. Okay, so it could be like the number of ways, that looks awful. Oh, that's even worse. Okay, it's the number of ways an event can occur. So like if you wanted to pick a queen out of a deck, the number of ways you can pull a queen. N of S in the total sample space. Oh my gosh. So I'm working on this. Okay, so that's what all of that means. Hopefully you can figure out my scribbling because, again, I'm writing on a touchscreen computer, which is not as easy as the school smartboard. Okay, and then this is saying that the probability has to be between 0 and 1. Okay, so when we talk about probability, it has to be between 0 and 1. Now, if the probability of an event is 1, that means it is certain to occur. It will absolutely occur. Okay, there's no chance of it not occurring. So in the case of rolling 1 dice, the probability of you getting an integer would be 1. Okay, if the probability is 0, that means the event cannot occur. So like if we're rolling a dice, the probability of rolling a 7 would be 0. The probability of rolling a fraction or a decimal would be 0. Okay, so if the probability of 1 means it will occur, a probability of 0 means it won't. So here we have a card is drawn at random from a well-shuffled deck of playing cards. What's the probability that it shows a number from 4 to 9 inclusive of those two numbers? So first of all, I hope you all know that a deck of cards has 52 cards. It has 4 suits of 13 cards each. Okay, and so we want to know the probability of pulling a 4 through 9, including those numbers. So that means you can get a 4, 5, 6, 7, 8, or 9. Now, if you count those up, that's 1, 2, 3, 4, 5, 6 possibilities. However, because of those 4 suits, there's actually 4 4s, 4 5s, 4 6s, 4 7s, 4 8s, 4 9s. So there's 6 possibilities for the number times 4 possibilities for the suit. So there's actually 24 ways that could happen. Okay, so to figure out the probability, this would be not P, N of E. Okay, 52, the total number of cards, that would be N of S. So to get the probability, P of E, we would do 24 over 52, which again, you can use your handy dandy calculator, a fully reduced fraction, math back, and that'll give you 6 out of 13. Okay, and we got that one right. Okay, so I think I'm going to pause here for this video, just because it's getting a little long, and then I will pick up with another one.